You don't see this RAM bus dynamic random access memory much anymore. You see it in some older systems, and occasionally you'll run across a computer that needs a memory upgrade. They may need this type of memory. We saw this memory. It was created by RAM bus. It was very specific to what they were doing. We saw this first introduced in some older systems, Pentium 4 systems with a 400 megahertz front side bus. And because of that, you can think back, gosh, that's a long time ago, a Pentium 4. Well, that is how long this technology has been around. As the name implies, RAM bus dynamic random access memory, it is a technology that was licensed by RAM bus. They created the technology. They don't build the chips. You can see, in fact, this is a RAM bus chip that's actually manufactured by Kingston. But this is something where RAM bus and Intel got together and said, we need memory to go faster. How can we do that? And RAM bus said, I have a great technology that will allow us to put these memory modules in that can now keep up with these faster processors that you're creating, Intel. Let's partner together and create some of that. The problem is that it didn't catch on very well. It is a licensed technology. There were costs associated with doing that. And so when you compare it to what we would use with that SD-RAM, you can see it's relatively expensive. You go back out and try to price that, especially now, it's harder and harder to find this RAM bus DRAM on your upgrade sites. You're finding that it's relatively expensive when you compare it to those other types. So when you get into those environments where you really need to upgrade the RAM bus memory inside of a machine, you may be paying a little bit more than what you're accustomed to paying on a system that is not using this RAM bus memory. Instead of using this RAM bus licensed technology, what the industry said was, let's use a different type. Let's use something called double data rate SD-RAM. This DDR is how we abbreviate it. DDR was this first type that allowed us to get very high data rates. And because it's the double data rate, it goes twice as fast as what you would normally see in what we call our ordinary SD-RAM. So this is the next generation now. Since we had the SD-RAM, this is what came along next. To be able to calculate the speeds of this, we're using a different set of nomenclature to describe it because there are many different ways to set up and use the memory in our system. We're not just using the clock rates now because we're essentially doubling the data rate on every time we use this clock rate. Let's say we have a memory clock rate or bus clock rate of 100 megahertz. And here, this is the calculation. I'm calculating the memory clock rate times the bus clock multiplier. In the case of DDR, the multiplier is a number 1. It's a dual rate on this memory, so it's times 2. We're transferring 64 bits on each clock rate, and if you do the calculations, you know that in a single byte, there are 8 bits. So at the end of this equation, we'll be dividing all of this by 8. So if we add up 100 megahertz, we multiply 100 megahertz times 1, well, that one's easy, times 2, and times 64, we get a total number of 12,800. If we divide that by 8, that's the number of bits transferred. We divide that by 8, we get the number of bytes transferred, which means that this memory can support 1,600 megabytes per second at a peak data rate. So this type of memory that's rated, the DDR that's rated for a 100 megahertz memory clock rate, we describe as a PC1600. So now instead of describing the speed of DDR as the clock rate, we're really describing the speed of DDR chips as its peak data rate. So that's a big difference. Now, fortunately, this is the only type of formula we need to really know for our A+ exam and how to calculate the peak data rate of certain types of memory. We just have to plug in the right numbers here. So not too bad in being able to do that. And you'll see once you do this twice, 3 times, it becomes a little bit easier to understand. DDR worked great for us, but we realized as the processor speeds and the bus speeds increased, we needed even faster capabilities. We came out with DDR2. DDR2 has a number of additional capabilities, a new electrical interface, there's more buffers, there's some other drivers that are on this or really off the chip here that allows us to go much faster. And because of this, there is a different calculation associated with it. Now it's 100 megahertz. I'm getting 2 as my bus clock multiplier on DDR2. It's dual rate again, that DDR type capability, 64 number of bits transferred, and again, 8 bits per byte. So the only thing that changed here is in the case of me calculating this for a 100 megahertz clock rate, I'm only changing the bus clock multiplier from DDR2 from a 1 to a 2. So it's the same calculation, except now I have 25,600 as my number of bits transferred. That's the number of bits on a peak data rate. If I divide by 8, that's the number of bytes, and I get 3,200 megabytes of a peak data rate. And you can see instead of doing PC dash, I use a PC2 to designate that this is DDR2 on my data rate. So if you're trying to buy memory and it says this is PC2 3200, you'll know immediately the PC2 means this is for a motherboard that can accept DDR2 memory. And then you'll see the peak data rate of 3200, and you can make sure this is spec'd properly for the motherboard you're buying it for.